Both working very hard to soak in the sun today, aren't we? Do you know how solar panels collect energy from the sun? The photoelectric phenomena explains how solar panels are able to capture energy from sunlight. But let's take a step back. What is light? Light is made up of pockets of energy called photons. A photon is a zero-mass electromagnetic radiation particle that represents a quantum or unit of light. Now let's take a closer look at the solar panel so we understand how the photoelectric effect works. The photoelectric effect occurs when a photon from a light source, such as the sun, hits an electron of a metal atom. The electron needs to absorb all the energy from the photon in order to have enough strength to escape or eject from the silicon atom in the surface of the metal. One photon is capable of creating one photoelectron, aka the ejected electron. The current that comes from the energy of captured photoelectrons in solar panels can be used as electricity to power your phones, laptops, lights, and more. But what happens if the photon does not have enough energy to give to the electron? In order for the electrons to be ejected from the surface of the metal, there needs to be a minimum frequency of the incident light, also called the threshold frequency, V sub 0. Frequency is the total number of waves that move across a certain area of space during a time interval of around 1 second. To visualize how the threshold frequency works, I'm an electron on the edge of a metal surface, or in this case the ring. My little sister is the light source and the soccer ball my sister is holding is a photon. If the frequency of light is below the threshold, the electrons will not be able to break free of the metal atom because they do not have enough energy to overcome the electrostatic force of the protons. So when my sister throws a ball with a lower force or frequency, I don't move. If the frequency of light V is at or above the threshold, the electrons will be able to eject from the surface of the metal. So when my sister throws a ball with a higher force or frequency above the threshold, I jump out of orbit. The higher the light frequency, the higher the kinetic energy of the ejected electrons. So the next time you see a solar panel, think of the photoelectric effect. But for now, we're going back to soaking up more sun.